Okay, so let's continue. We just went to the server room. What did you see? What are some of your reflections, your observations from the server room? Were you surprised by anything? Was it cooler than you expected in terms of temperature? Were there things that you were expecting to be there that you didn't see? Let me know. Were there? It's what? It's cold. Okay, so let's touch on that a bit. We're gonna go. Okay, so what type of resources did you see? We were mentioning storage. Okay, so lots of hard drives, memory. We talked about RAM. Also, we're gonna go in detail into those. Lots of computing resources. Okay, so all of those blades that you were seeing, all of those processing units, some of the GPUs we were talking about, those are used for computing. And one of the examples we highlighted was for weather prediction. A lot of the research that I do also uses lots of computing, and I'll touch upon those on Wednesday. So what are other things that are needed so that you use these resources efficiently, other than storage and computing? What comes to your mind? Let's see what's... Okay, so we mentioned, other than those resources, networking or communications. Now that you have all of these resources with massive storage and computing power, and you have many of them, another obstacle or bottleneck now becomes the communication between them. Okay? I need processor 8 to run this problem for me. For me to send the inputs of this problem, I need to send it somehow, right? The communication link that I send this through it, I have to pay for it. Okay, so you have internet at home, I guess a lot of you. What's the speed of the internet that you have at home? One of you. 1 gigabit per second. So you pay for that, right? Depending on what type of technology it's based on and which company you're getting it from, it might be dedicated and it might be up to that. Let's assume it's dedicated. That is a stream of data that you can get per second. Now, that represents the communication link. If you need more than that, what do? You have to pay more, right? So you're going to see that on Amazon EC2, what you're sending and receiving, you basically pay for it depending on how massive your data is. Don't worry, you're not paying anything. The other element that is required specifically for storage is fast access to systems. So you need to be able to read and write pretty fast. We're sending big chunk of data that is used as input to solve a problem. Okay? So let's say what I'm using for weather prediction is historical data during this time. Then there are measurements from different observation units that are used also as inputs. Based on those, there's prediction of where the clouds are, where they're going to be, where when the next storm is going to hit, all of those things. And those things have improved throughout the years, right? Previously, we didn't know that those things as fast. When you send this information to these resources, you need to be able to write them pretty fast. Because if I'm going to send, then I'm going to wait for it to write, it's going to take hours, then it's not worth it. Okay, so that's another place where the technology has improved quite a bit in reading and writing. In general, reading is pretty fast. You can read from the same place through, like let's say 10 different units can read from the same place. But writing is a bit more difficult because you don't want to write, you don't want two people to write at the same place, right? So there are issues like that. You also don't want to write something and then when a different processor is reading it, you don't want it to read the old information, you want it to read the new one. So there's a lot of programming that goes into solving those issues. OK, so the units, we mentioned computer systems, telecommunications, so communication specifically, and storage systems. Some of the other elements are backup power supplies. So if we lose power in the whole university, the server room is still going to be working. There are separate power supplies for those because those can't go down. If those go down, nothing's going to work. And if things heat up, then that's a lot of investment gone down the drain. So if you're too warm at any point of time, you can go there, even if there's no electricity anywhere else. That's not an issue here, but you never know. When you have a flood, like what happened a few weeks ago, you might lose electricity in some places in the city. So data communication, the connections, you have security devices. We mentioned firewalls. What are firewalls? If you're using Windows, your computer says your firewall is not on. How is that a problem, or why could that be a problem? Louder, louder. You're exposed to danger. So all of these resources that you have, if someone accesses them, then they now have control over massive resources through which they can do bad things, malicious things. So that's why you need to make sure that no one comes into those resources. Okay? So that desktop that we saw on top of those blades, so computer blades, which are, as we said, like a full computer, each of them, those are usually configured with firewall settings. So the way you enter and you exit from it is pretty limited. And we do get lots of hackers trying to go into those resources several times a month. Okay? And big, big attacks. That's why those are very important. And we mentioned air conditioning and also fire suppression. The air pressure and things like that need also be controlled. OK, so what you saw is a server room. Its components create what is called as a traditional data center. OK? So a lot of the data centers of your, let's say, your Google, your Facebook, your Apple, maybe 10 years ago, 15 years ago, looked like this. OK? That's why I took you there. What are some of the issues that you perceive with this? Is it too cold here? Is it making you sleepy? Come on, you gotta interact with me. We're gonna learn together. With the resources that you saw, okay? We mentioned storage. We mentioned the maintenance. What's gonna happen if we have more students? You have more people that need to use that. What do? You add more resources, and then what? Space, right? Space, and then all of a sudden your air conditioning isn't enough. So there's a lot of changes that you need to do, a lot of patching changes, and a lot of problems occurring towards that. OK, let's see. So let's look at it from a different perspective. What if these resources are not for a university? Okay, what if it's not, let's say, professors, servers, graduate student research experiments? What if it's for Google or a bank? What if your banking information is there? Okay. What if your emails are there? Yeah.
Will they need to be encrypted?
They need to be encrypted. You have lots of limitations such as that. But I'm talking further in the perspective of maintenance, and then problems occurring, and then let's say hard drives stopping from working, or having a power outage. If you have a power outage there for an hour or two, that's fine. The professor will get their email 2 hours later. The research experiment, okay, you lose some time, then you rerun it. That's fine. But what if it's a bank? Huh? Some of your data might be lost. What else? You can't do anything. You lose your money, right? You might lose your money. Someone might steal it during that time. Okay, so we're starting to see problems, right? And what if, let's say, how many of you are from Canada? Okay, almost half. So some of the 4, 5, 6 banks have millions of customers, okay? And in other places of the world also, there are lots of big banks. Imagine before Christmas, and I don't know, millions of people are trying to access that server that instant to get money. Does a server room like that handle it? No, right? So especially with that bulky firewall thing, it's not going to happen. What would be the limitation there? What would be the limitation there? Out of the resources that we mentioned. Is it storage? No. It's communications. Okay? Because the links that are coming in, they're limited. If everyone is trying to access them, it's going to be limited, and they're going to be left in a queue. And after a big queue, messages would be dropped. People are not going to be happy. Especially if they want their money, they're not going to be happy. And such things, for example, happen in very often. Not very often, but once in a while. It happened in Cyprus like a few months ago, let's say, because everyone wanted their money with the banking issues there. OK, so usually need far more storage, far more computing power, and far better communications, and guarantee that communications. So you need lots of redundancy. So we were mentioning how you can't be using everything at the same time, because if an issue happens, then you don't have any redundancy. So you end up depending on the ratios that you want, if you want everything to be backed up by another one, then you're basically using half of your resources. It depends how you want to do it. But in any case, you're losing a lot of money by having redundancy so that you don't have all of those issues, right? Now, when you look at banks, let's say, when you have huge databases, we mentioned how read and write takes time. So if several people are reading or writing at the same time, it's going to take longer for that operation to happen. Because of the reading and writing. And the other thing is authentication. Okay, so security, we mentioned firewalls. So if people are trying to go in and get their money, you want to make sure that they are who they tell you they are. Okay? That's usually done by username, password. There are different keys that you can use. For licensed software, you use something called dongles, USB dongles that prove that you physically have it. They mail that to you. So one of the things that happened a few years ago is for one bank account, $400 was withdrawn from every ATM, and they used 1,000 ATMs. Okay? So the guy had $400 in his account. He made copies somehow of his cards, 1,000 copies, 1,000 different places, even it was in several countries. This was in Europe. And at the same time, within seconds, he withdrew $400 from each device, 1,000 different people. So the $400 that he had, he cashed out 400, how much? $400,000. Could you imagine that? This is more than 5, maybe 10 years ago even. So how could that happen? The information wasn't transferred quickly enough. Plus, the checks that were made were not enough, because you want to make sure that no one else is trying to get any money from this account when you're actually spilling out the $400 from that ATM. So one of the issues that happens with big storage, big institutions, is you need to be able to handle large numbers. If you can't handle large numbers, you'll be losing money. You'll be losing $400,000 minus 400. So unless you can handle those resources, you have all those servers, you will have problems like this. OK, so we're starting to see the different issues that we might get from cloud computing. Yeah. OK, now let's go. Who's familiar with what a boxing sale is? OK, so can one of you explain it to your other colleagues? Go ahead. Yeah. Loud, loud.
Not too sure.
OK, someone else. Yeah. Be loud so that everyone hears it.
Yeah. When everyone's buying cheap stuff.
OK, so it's the day after Christmas Eve when everyone is buying cheap stuff. So it's called Boxing Day. A lot of the stores open up at like 7 a.m. You have queues at 5. Some of the electronics stuff are now online. They start at 8 p.m. or 10 p.m. the night before. That's the only thing I buy. I don't go to an actual store. People are really crazy during that day. In some of the clothing stores, especially some of the women clothing stores, you have people fighting over dresses and then tearing them on Boxing Day. That's very common. So especially because you want your exact size, right? You don't want a wrong size. And if you find something that fits, that's it. So, and the prices go down by like to 10, 15%. So like they go down by 70, 80% basically. So during this time, a lot of the basically retail places, retail businesses, have changed a lot of this into going online. Okay? So not just for electronics, a lot of the other stuff have gone to online. It's less money for them. They can ship you the device from somewhere else. They don't have to, pay for transportation fees to a particular store. But it creates other issues, other IT issues. So formally, it's a secular holiday that gets celebrated on December 26th. It's after Christmas Day in Britain, Canada, New Zealand, and some other states, some states of Australia. A similar thing in the States is called Black Friday. It happens in, I think, November. So just a number from Wikipedia. In the UK in 2009, it was estimated that up to 12 million shoppers appeared at the sales. Appeared at the sales means physically appeared at the sales. Okay? And you just imagine the number that are sitting in front of a computer trying to have a different transaction. Now, and a lot of these now have gone to online. OK. So now let's go back to traditional data centers and then imagine the demand that you have for computing resources for the servers of these retailers, these electronic shops, your, I don't know, your Apple, your Google Play devices, all of those things that are happening online. When you have such a high demand, what do? You're the company. You're Apple. You're Apple, and on that day you have, I don't know, 2 billion people buying an Apple device. It's not a joke. It's possible. Let's say 1 billion around the world. Huh? Line up?
Yeah, say
No. From a server's perspective. From a, what do you do? How many hard drives do you put? Of what size? What processors do you put? How do you guarantee those links? How do you make sure that when someone is coming in to buy a $1,500 MacBook and they press pay, they put their credit card information and then next, that transaction actually finishes all the way to the end? Because if you have somewhere in the middle, if you're stuck, if something happens, you don't know if the money got paid. If you don't know if the credit card company got the money, you didn't get it. So that whole transaction, that retail transaction, needs to be guaranteed. That gets sent into shipment, packaging, shipment, and then gets shipped to the place. Okay? And this is happening for millions at the same time. Okay? So the issues that we were mentioning before. You need to have extra storage, computing, communications available and ready for all of these. Okay? So if you need particular unit, I'm not going to just throw numbers now, particular unit per transaction, if you have 1 million of them, then you need 1 million of those. Or else the delay is going to be, instead of, let's say, 1 minute, it's going to be 1 million minutes. So no one's going to wait 1 million minutes to get something online, right? OK, so imagine that you did actually put all those servers, get all those resources for Boxing Day. And then after Boxing Day is done, everyone's like not online anymore. They're on vacation somewhere in Cuba, let's say. Then what do? Yeah.
Use more of them to process each order to make it faster.
Well, the orders are done. Let's say January 10, everything's shipped. Everyone's back to school. No one's buying anything. No one has money to buy anything. But as a company, all those resources that you bought and set up in place, what do you do with them? Are you still turning all of them on, keeping the AC on? Shut them off. OK, shut them off. You paid $100,000 for a server. What do you do with it? Huh? No one needs it. There's a huge demand during that time, and after that, there's nothing. So you're starting to get the problem, right? You have a lot of resources that are going to be wasted. Okay? These extreme high demands, they don't happen every day. They happen rarely. However, you still need to meet those demands. Okay? You need to have the resources so that those demands are met. Now, let's talk about smaller companies. Let's say you have a smaller version of your Apple, your Google, your, I don't know, your retailer. How do they deal with these? How do they compete? What if they've accounted for 100 people showing up online and buying devices and 2,000 people show up? If they fail, that's it. No one's going to come and purchase anything from them again. Right? Especially if only 5%, 100 out of 2,000, actually get their demands met. So if they don't have those resources, if they don't have enough money to buy all of those resources to guarantee it, then they won't be able to compete. And this is going to lose a lot of, they're going to lose a lot of clients unless they have all of those resources. OK. So now we're trying to formalize the problem from an engineering point of view, plus also it's partially an economic point of view. So how do you deal with varying demand? OK? That is the problem that cloud computing tries to solve. And we're going to see that a lot of the smart infrastructure elements in different fields are also trying to solve the same problem. OK? Varying demand. You have huge peaks during particular times, then during other times, it's very low demand. So one element, as we said, is over-provisioning. So making sure you have redundant resources, you prepare for the worst, and you need to have, you pay for those resources. And we're saying that that's not the only way you can solve this problem. Okay, there is another way. And that way starts with the thought process of, why don't I use the resources that I need only when I need it? I don't get that many servers. I get the servers that I need only when I need them. So if you think about it from this perspective, it's the notion of renting. Renting rather than buying. So if I need a car for a weekend, 1 weekend a month, doesn't make sense for me to buy a car, does it? Right? There's a lot of costs associated with the maintenance and all of those things, insurance and those things. So you only rent when you need it. When you don't need it, you return it. Okay? So that's the notion, but it's the notion of renting computing resources. And you basically return these resources when your demands go back to normal. So this possibly sounds cost effective. Okay, so one example is party rentals. Have you heard of party rentals? So party rentals offer things such as chairs and covers, tables, tablecloths, silver and flatware, dishes, glassware, all of these devices. So if someone is having a big party, they're not going to have 50 sets of cutlery. I don't know, 50 plates, champagne glasses, and so many things. They're not going to have them, right? They could buy them, but that's also a big investment, and they might not use it. They might only use it once a year or once every few years, right? That's why there is something called party rentals, where they come and provide all these devices for you for a day, and then they come and pick them up and go. So you just get them for the party. The party could be high demand, basically high demand for coming to your place, and then you return them. Because buying them and storing them costs money, uses up space, not to mention power. Okay? Some of these devices, if you need, let's say, a chocolate, I forgot what it's called, a chocolate fountain, that needs electricity, right? You're not going to need it every day. You're only going to use it for a party. So if you consider also the servers, if you're keeping them on, you need to cool up the place, cool down the place for these, and that costs a lot of power other than like turning them on. Okay, so let me just mention one of these. One of the biggest costs for maintaining data centers is the power, as I mentioned. So the average cost for an average server of, let's say, $100,000, the cost of cooling it every year is $10,000. It's not 10, it's not 100, it's $10,000. That's a huge, huge cost just to cool it down. Okay, so let's see. So depending on how big the facility is, the power would go from kilowatts, so from a few kilowatts to tens of megawatts in order to for these resources. So we've been hearing a lot about green data centers, so designing new data centers that are more power efficient. And the point of view is to bring down the cooling costs. That brings down the cost of other stuff. So you have examples are seawater cooled Google data center. So they put it next to the sea. They use the water to cool it. And you have a data center. Facebook has a data center in the North Pole. One of the more recent things that I saw a few days ago on TV are underground data centers. When you go down, deep down, you have like cities underground that are only data centers and people managing them. It's cooler, so you reduce your cost by more than 50%. And it's also more secure, because how the heck is someone from outside going to physically go and reach those data centers, right? So these are growing companies that are providing those services to other companies. Underground data centers. OK, so what does cloud computing offer? Cloud computing offers a new computational model. So some of the different ways that cloud computing works. First, you have software. So computing and storage is provided at servers. Let's see. So software is hosted, run, and administered in a large data center. So all of that is running somewhere else, and you just receive the output of it. And from your perspective, from the computing utility, you're running everything there. You're not using your own resources, but you feel like you have unlimited resources. OK? So illusion of infinite resources. The other thing is there's no upfront cost. I don't pay ahead of time for that service. I only pay for what I use when I use it. And flexible billing, so based on that. So let me explain this first. And the key technology here is virtualization. So from a company who's providing this service, if 20 of us, let's say, are trying to access resources from the Amazon EC2, what are they supposed to do? They have huge, massive resources. Let's take storage, huge hard drive. They divide it into pieces, and based on what we require out of it, they virtualize it, and then we can use it the way we want. So you have your hardware, you have your operating system on it, and you can have different applications running on it. Now, this is what happens on Windows, let's say. What happens in a virtualized stack is you can actually have this additional module called the hypervisor. This does the job of the language between the operating system and the hardware. The operating system is like Windows, Linux, the Mac OS. And you have the app on top. So what happens is you can actually be running different operating systems on the same device. And these could be for different people. So what Amazon does is they own this thing. They own this hardware. They run these, and they build different people using the same device based on their different usage. OK? And these do not have to be the same size or shape. If you use 10, you pay 10. And someone else uses one unit, they pay for 1 unit. And you can have this, so multiple virtual machines running on a single physical device. So the notion of virtual machine is you take a device, you virtualize the usage, and what you see from a client's perspective is, I want, let's say, 2 gig of RAM, 2 cores of, I don't know, 2 gigahertz per second each of this particular type, and I want this OS on it. That's what I get. Someone else might be asking for something else. So you have Windows, NetBSD, and Linux. So different operating systems here. And what this offers, so the essential characteristics, is on-demand self-service. So depending on what I want, when I don't want it, so it's like on-demand video, right? I can get it. The broad network access. Another aspect that is virtualized is the networking resources. So among the links and the resources that I have, those are also virtualized. So the big links that they have, let's say, the 1 gig is divided into smaller pieces and built based on different people's usage. Resource pooling. So this is if if one of those hard drives or servers went down, that is not my problem. If I get if I use a cloud service, then that needs to be guaranteed for me. They need to handle redundancy. They need to handle other issues. And different resources will be provided for me in order to solve my problem if there are issues happening. And rapid elasticity, so this is with time, you have you can do quick changes. So if your demand or what you're requiring from these resources is changing, you can get the responses pretty quickly. And measured service, you will be, whatever you're getting is being accurately measured, and you only pay for that. So let me show you how this works. So the economics of this works in the following way. On a static data center, we said that we have demand that is changing, okay, over time. And this is on the y-axis, you have the resources. So the demand for the resources is changing over time. I can actually use this, okay? So it's changing over time. And this is the capacity that you have if you are using your traditional data center. So why is the capacity constant? Yeah, so you only have a certain amount of storage and processing and communication. So your resources are limited. You've paid for this much. Excuse me. So that's what you have. And you're also paying for this, right? You're paying for this all the time. So you bought it. You're also maintaining. You're paying for the maintenance cost all the time. And your demand is changing. So what's different in the cloud, so if you have a data center that's using cloud resources, is your capacity that you're getting is far closer to your demand. Of course, it can't be exactly equal to the demand because we do need still that additional room of redundancy. But it's pretty close. You don't have that much of a difference between the two curves. So the demand is here. The capacity is very close to it. Yeah?
How do you know your demand peak won't rise?
If it rises, then you change your capacity. So if the demand goes up, then you increase your capacity. You do it while it's happening. Okay? That's why you need this additional room, so that you give yourself time to get the new resources. Okay? If you don't leave that additional room, then people wanting their money will not be getting their money. People trying to get transactions happening, some of them will not go through. As long as the client is happy, and as long as their demand is below capacity, the client is happy, you're making money, everyone's happy. Okay? So now you see this gray. This gray is the unused resources. So those are the resources that you're paying for, but you're not actually using. So for the static data center, the unused resources are a lot. For the cloud computing, the unused resources are minimal. Okay? As we said, they're minimal because you want that redundancy and you want that time to adjust to changes that might happen. Okay. So another way to look at it is, let's see, is in here. This is, if you don't have the full capacity, let's assume your capacity is here, then the parts here would be lost revenue. So those are people coming in and trying to run transactions through your system. If you can't satisfy those demands, then you're losing revenue there. Another way to look at it is users will start decrease, and then you're actually losing that demand. Those people are not going to come back. OK, so measured service is basically an optimization of the usage of the resources. Once you know that, let's say, thousands of people need these resources, I can allocate them. I can give them those resources from different places, right? And I can also better monitor what's happening throughout. I know which systems are working for me. If there are issues, as I said, I provide them additional resources. A hard drive is done. They have redundancy from another hard drive on another system. And based on that, then I send them the billing. OK, so cloud computing models, you're going to mention 3. There's software as a service. Let me just mention the 3 of them, and then I'll go back to each of them. There's software as a service, platform as a service, and infrastructure as a service. So software as a service, from the client's perspective, everything is happening on the cloud. The only thing that you see are the services or the applications. OK, so you don't care about the underneath layers. So the applications go through a very thin client interface. One example is Gmail. Another example is Quicken Online. So these are just barely the applications. Everything, as we said, is running on the systems. Another one is platform as a service. So in here, you get the platform in which you can do some programming, programming the environment. You can change some of the ways you're using the resources. So an example of this is Google App Engine. So if you do have that background, you can do some programming. You can change some of the OS here and basically run the engine, run different applications on top. Okay, that's why you have the programming environment, and then on top of it, you can put whatever you want. But you have control over this too. And finally, you have infrastructure as a service. Here, you go down to the lowest level. So customer can deploy and run arbitrary software. You manage the infrastructure. You have everything from like the core, and that's guaranteed for you. Okay, so you're at the level of basically the storage and processing, and you can put whatever operating system you want on it. And this is what Amazon EC2, which we'll be using, it has capabilities up to here. So it can give us all of these. Okay, so you can choose things such as the CPUs, what type of virtual machines we want on them, and all of those things. Now, of course, from a pricing point of view, it makes sense that the higher things are, the more simplified things are for you. They're a bit more expensive. But from a different perspective, depending on your knowledge, the more you can do stuff by yourself and you manage them by yourself, you can go to lower levels. So you can do platform as a service or infrastructure as a service, depending on your knowledge, basically. OK, so there are a few more slides about cloud computing. Then we're going to go to a video. So the deployment models, there are different ways that companies now are using cloud computing. There's the public cloud. So this is everything is done at another facility by a different company, and you don't own any of those resources. Another one is private cloud. So you set up your own cloud computing service on your system. That is, we'll discuss these, but there are particular cases where that might be helpful, especially if you don't want to, let's say, share some of your sensitive data and things like that. You want to make sure you have all of those in-house. You don't want that to be run through another company. Community cloud, this is owned by several different organizations together. And hybrid is a composition of 2 together. So it could be that you have public and private together make hybrid. So the parts that are not as sensitive, you have them as public. The ones that are sensitive, you have them as private. OK, so the economics, why are people using it? Why are you hearing it so much? Why are you learning about it? It's because for network storage and administration, the costs are reduced by these skills. So around 7 times, 5.7, around 7 times, the prices go down. And this is for, these are the costs in medium data center, and this is the cost for a very large data center. Okay? And these are, over the years, these are also, like, the prices are going down, but the ratios would actually go up.